In this video we're going to look at the three different types of modern storage cells, which you might call batteries, for example. The three types are primary cells, secondary cells and fuel cells. A lot of the equations that we're going to see you don't actually need to memorize. You will be given them in the exam when you need them, but it's helpful to be familiar with them, particularly the fuel cells. So a primary cell, that'll be the kind of battery you might buy from your local newsagents, which you use for a while then throw away. Okay, it's non-rechargeable. You use it, well, I say you only use once. It's used up. Yeah, it's used until it's used up. Okay, and then the chemicals are gone. It's gone flat. So, like, think about your AA batteries you might put in your remote control, that kind of thing. Most of them, not all of them, most of them are based on zinc, manganate in potassium hydroxide. So that's manganese 4 oxide, zinc manganese 4 oxide. So you've got these, here's the two half equations. This one's more negative, it would go backwards, hence the zinc is a reactant. This one's more positive, it goes forward. So they've got 2 electrons, they cancel out. They've got water on either side, they cancel out. And hydroxide ions cancel out in the overall reaction to make this overall equation. So you've got the zinc reacting with the manganese 4 oxide, and it gives you a voltage of plus 1.43 volts. Like I said, you're not expected to memorise any of this. Anything that you need like this will be given to you in the exam. The main thing to know about a primary cell is that once it's used up, these reactions cannot be reversed. You can't go back to zinc and manganese 4 oxide again. So ones that can be reversed are rechargeable batteries, secondary cells. Your battery in your car gets recharged all the time when you're running your engine. These are the type of batteries you can recharge, like for example you might have them in a torch that you can recharge, something like that. Or I'm just thinking, like, my kids have got remote control cars, that, you know, toy cars that they recharge. That'd be that type of battery. Okay. Another example is what's in your phone, your laptop, your tablet. Okay, something you're probably watching this video on right now. It's got a lithium ion or slightly different version of lithium ion polymer battery. Okay, these are all rechargeable. When you charge it, you do the reverse of the reaction that you did to make the voltage in the first place. So by putting electricity in, you reverse the reactions and you go back to the starting chemicals. Okay, so the chemicals are regenerated. If you look at on the PowerPoint, there's a video of one of the problems with particularly the lithium ion is that it can cause fires. If they get too hot, it can cause fires. And this particular problem is being seen in recycling centres when the batteries are in waste that they didn't know was there. When it's been crushed and sorted, it's caused fires. Enjoy that video. Okay, the third and final type are fuel cells. Basically, you take a fuel and you add oxygen to it and you get a voltage. So previously you had seen fuel plus oxygen makes heat, combustion, isn't it? This is fuel plus oxygen making voltage. And provided you're continuously topping up the fuel, so you don't let that run out, and there's constantly oxygen present, you know, being fed through an air vent or whatever, then you get a voltage produced. So the most common one you'll see, we'll look at quickly here, is the hydrogen fuel cell. Another one that's similar to it, which also has a lot of hydrogen in its formula, is methanol. And the advantage of the methanol fuel cell is that methanol at room temperature is a liquid, so it's easy to store. Big problem with the hydrogen fuel cell is it's a gas, and obviously you don't get many moles per volume with a gas. You know, 1 mole of gas occupies 24 dm cubed at room temperature, so that's an issue. So how you store the hydrogen is probably one of the biggest problems. But one of the biggest advantages is that it's very efficient. The efficiency of a hydrogen fuel cell is almost double that of a combustion engine that you have in, mostly have in cars at the moment. Now, there's 2 types. Again, you're not expected to memorise any of these reactions: alkali hydrogen fuel cell or the acid hydrogen fuel cell. Obviously, the difference between is pretty obvious, but the electrolyte, the solution in the alkali hydrogen fuel cell, is has OH- ions, and the acid one has H+ ions. So You see in both of them, hydrogen's fed in, hydrogen gas, oxygen gas has to come in as well, and the only waste product is water. So this is one of the big benefits of it. If you imagine all the cars driving along, the only thing they're giving out is water. No carbon dioxide, no nasty gases. Okay, in this one, the hydrogen reacts with the hydroxide ions. This one's more negative, so it goes backwards. You can see here it is written out again. Okay, produce water and electrons. The reduction that occurs is the oxygen reacting with the water plus the electrons to make hydroxide ions. So you can see they cancel out. Basically, you've got hydrogen plus oxygen makes water, 1.23 volts. Similar thing here, you still got 1.23 volts. This is basically the formula for the standard hydrogen half cell, so hence it's 0. Then you've got oxygen plus H+, again it's been the oxygens being reduced, just the same as it was before, and that produces water. So overall same reaction, overall same voltage. Okay, so rather than combusting hydrogen, rather than, although this is the same as the combustion reaction for hydrogen, we're not combusting it. We've got two separate half cells producing electricity. So what are the disadvantages of this? We mentioned that hydrogen is a gas, it's very hard to store. Also, although we're only producing water, this can't really be considered carbon neutral, because where's the hydrogen come from in the first place? Hydrogen is mostly produced from fossil fuels as a sort of almost a byproduct. It can also be produced by electrolysis of water, but then you need electricity to do electrolysis of water. That could be done by renewable sources, but probably at the moment it wouldn't be. So there's development here. Okay, things to be developed and to be looked at.